So here's something most people never think about. When you type a message into an AI product, the model that replies to you might not be the one you think you are talking to. And that's not an accident. Behind the scenes, there's an entire routing system making that decision in milliseconds. Today we are breaking down how LLM routing actually works, what it is, why companies build it, and how it decides which model gets your question. So let's get into that. At its core, LLM routing is exactly what it sounds like. It's a system that sits between the user and the model, and it decides which model should handle this specific request. Think of it like a traffic controller at an airport. Not every flight needs the same runway. Some requests are short and simple, some are long and complex. Some needs to be fast, some needs to be accurate. So routing is a logic that figures out that right match. And this is happening at a very massive scale inside products like ChatGPT, Perplexity, Google's AI mode, and a bunch of enterprise apps you've probably used. Here's a fundamental tension that makes routing necessary. Frontier models like your GPTs, your Cloud Opus, they're incredibly powerful, but they're also expensive and slower. Running every single user query through a frontier model would cost platforms an insane amount of money. On the other hand, smaller, faster models are much cheaper, but they can't handle everything well. So the question becomes, can we intelligently route simple questions to cheap models and then send the hard stuff to the expensive ones? So that's the whole game. And it turns out most questions don't actually need the best model. They just need a good enough model and which is fast. So when a router evaluates a request, it's basically scoring it across three dimensions. First is latency. Does this need to come back instantly or can it take a few seconds? A live customer chat, it should be fast. A background summarization job, it doesn't matter. Second, complexity. Is this a simple lookup or does it require multi-step reasoning, code generation, nuanced judgment? Third, cost. What's platform willing to spend per query? Enterprise customers might get better models. Free tier users might get routed to a faster, smaller model by default. So these three dimensions together drive most routing decisions. Now let's get into the actual strategies. There's not one way to route. There are several and most production systems use a mix. The simplest is rule-based routing. You write an explicit if and then logic. If the query is under 50 tokens and doesn't contain code keywords, send it to the small model. It's cheap to run, predictable but brittle. Then there's classifier-based routing. You train a small, lightweight classifier model that reads the query and predicts which bucket it falls into. Simple, medium, and complex. It is way more flexible. After that, you have something called the cascade routing. You start with the cheapest model, evaluate the confidence of its answer, and if it's not confident enough, you escalate to a stronger model. And finally, LLM as a judge routing, where a small model actually evaluates the incoming query and decides the routing itself. It is a bit meta, but it works surprisingly well. Now, cascade routing is probably the most elegant of those strategies, so let me spend a moment on that. The idea is you start cheap and you escalate only when you need to. The small model takes a shot at the query. If it answers with high confidence, done, cheap and fast. But if the model's confidence score is low or the answer looks a little uncertain, you escalate that. The same query gets sent into a more powerful model, but the tricky part here is that defining what the low confidence means. So that's usually a combination of log probabilities from the model's output distribution or a separate classifier watching for hedging languages like I'm not sure or this depends on. When done right, cascade routing can give you a frontier model quality at a fraction of cost because most queries never reach that expensive model. Here's where it gets really interesting. Semantic routing takes this to a whole new level. Instead of looking at keywords or token counts, it actually embeds a query. That is, it converts it into a vector in a semantic space and then matches it to a predefined clusters of query types. So, how do I reverse a linked list in Python? Doesn't get routed because it has the word Python in it. It gets routed because its vector representation is semantically close to the cluster of programming help queries. And this matters because language is a little messy and the same intent can be phrased 100 different ways and keyword matching breaks down fast. Semantic routing is much more robust, more accurate, and it becomes the default in serious production systems. Well, let's ground this in something real. OpenAI's ChatGPT is a great example of routing in the wild. They have multiple models in the lineup: GPT-4o Mini, GPT-4o, GPT-5, and O series reasoning models. And depending on your subscription tier and your query type, you're being routed differently. Free users largely hit GPT-4o Mini for most queries. Plus users get GPT-4o as the default. But even with Plus, if you ask something the system determines needs deep reasoning, say a complex math proof or a multi-step login problem, it might route you to O3 or O4 Mini. The thing is, OpenAI doesn't publish the exact routing logic, but from the observed behavior, it's a combination of user tier, query complexity signals, and current load on the model clusters. Perplexity is another fascinating case. They've built their own model lineup, that is the Sonar models, specifically optimized for search and routing. When you type a query into Perplexity, it's not just going to one model. So there's a classifier figuring this out. Like, this is a quick factual lookup, or is this a heavy research question that needs sources and synthesis? Does this need a live web call? Simple queries hit their fast Sonar small model, and complex research queries go to the Sonar large. And there's a whole layer on top handling tool orchestration, deciding when to trigger a web search, when to pull from the index, and how to stitch these results together. They basically built a routing first architecture from ground up. There's a deep trade off here that every platform building on top of LLMs has to navigate. If your routing is too aggressive, too eager to push traffic to smaller models, you'll save money but you'll degrade the user experience. Users will notice when answers feel shallow or wrong. On the flip side, if you're too conservative and always route to the big model, you'll blow up your compute budget. The sweet spot is somewhere in the middle, and it's not a static setting. It shifts based on the user behavior, query mix, model improvements over time, and the actual cost curves of the models you're using. The teams doing this well are running constant evals, measuring quality outcomes against cost per query, and tuning the model thresholds dynamically. You don't have to build routing from scratch. There's a growing ecosystem of tools that abstracts this. Route LLM is an open source framework that lets you plug in different routing strategies and benchmark them. Light LLM handles model gateway routing with fallbacks built in. Martian and Portkey are commercial router products that sit in front of your model calls and make routing decisions for you. Langchain has a router chain abstraction if you're already in that ecosystem, and that space is moving pretty fast. A year ago, most teams were rolling their own routing logic. Now, there are mature libraries that handle most of it out of the box. If you're building an LLM powered product in 2026, you should at least know these exist. So if you're building something with LLMs, and at this point, a lot of you probably are or will be, routing should be on a radar from day one. The mistake most people make is building for one model, optimizing for it, and then being shocked at the cost when they scale. Instead, think about your query distribution early. What percentage of your traffic is actually complex? Profile it. Test your use case against a cheaper model first. You might be surprised how often a smaller model is good enough. And when you do need to route, treat it as a production decision and not just an infra one. The routing threshold you pick directly affects your user's experience, and that's not a setting to just leave at default. Alright, so let's wrap this up. LLM routing is invisible layer that makes AI products economically viable at scale. It decides which model answers you based on cost, latency, and how complex your question actually is. And there are multiple strategies, from simple rules to cascade routing to semantic embeddings. And the right one depends on your own use case. Big platforms are already doing this aggressively, and tooling for developers is maturing fast. If you're building in the space, routing isn't optional anymore. It's a core part of your architecture. If you found this useful, hit subscribe. I drop videos like this every week on AI engineering and system design. And let me know in the comments what topics do you want to go deeper on the next one. Thank you.